everyone. This video is going to go over the Chapter 9 test review so we can make sure that you're ready for your test. We'll jump right into this first section. So 1 through 5 says write each number as a fraction or whole number. Basically, they want you to evaluate here. And all of these are ones that could have been fair game on like the no calculator part of your quiz. Sorry, I'm just trying to... There we go. That looks a little better. You can use a calculator on all of these. And this first one especially, that's a common log, so your calculator would do that for you directly. But let's just talk about it as though you didn't have a calculator, because I think it's almost easier to do that way. With the decimal points, remember that these are negative powers of 10, and I'm using 10 because this is a common log. And so this is 1, 2, 3, 4 places after the decimal point. So this would be a negative 4. Again, what we're really saying there is that 10 to the power of what makes that 0.0001, and so that would be 10 to the power of negative 4. Okay, that's really what the question is asking about that 0.0001. Okay, so then for this next one, log base 3 of 81, what I'm really saying here is 3 to the power of what gives me 81. Okay, and so again, off the top of your head, I would hope that you would just know the answer to that one is 4. So these ones that we really emphasize for you to do without a calculator, like I said, obviously you've got a calculator available to you now, but I think that it's quicker to do things like 1 and 2 here in your head, and even number 3. Number 3 is easier than the other two even. Okay, so let me get to the end of this section and then I will show you quick how you could do these on a calculator if you had kind of a brain fart moment and didn't know how to get to the answer. Okay, so these ones here, these are the ones we talked about, that if the base matches this number here, the answer is just the exponent. So my answer here is going to be 15. All right, and the reason for that is if I were to spin this log around to exponential form, it's really saying 11 to the power of what is equivalent to 11 to the 15th power. All right, and then it's just a matter of saying what would need to go in that box. Well, it would have to be a 15. Okay, so anytime this number and this number match, you can just go with the exponent. Okay, so that next one, log base 1/2 of 8, this one's a little bit awkward because we don't usually do fractions as bases, but I see the question that they're trying to ask. It's 1/2 to the power of what must make 8? Okay, so we've done one similar to this before. I don't know that we've ever done a fraction turning into a whole number, but it's going to work just like if I were taking a whole number and turning it into a fraction. I'm going to need a negative exponent here. A negative exponent is going to take this thing and flip it over so it's over 1. Okay, so it's going to be negative something. And then to turn a 2 into an 8, I would need a 3. Okay. All right. And then for this one here, I would always start with these crazy radical ones by taking this thing and rewriting it with an exponent. Okay, I would get rid of this and I would write it as 5 to the power of 1/3 because that's the same thing as a cube root of 5. Okay, and then we've got the same situation that we had here in number 3, is we have a base of 5 and this number is 5, so then my answer is just the exponent of 1/3. Okay. The one quick thing I wanted to show you here, let's see, just kind of do this down the side, is if you didn't know how to get these answers off the top of your head, if you didn't know how to come up with that or this or anything, we could use the change of base property. Okay, and change of base says, sorry, I'm just writing it in here so you know what I'm doing. Change of base says if I'm trying to do log base b of x, I can also do a common log of x divided by a common log of b. And you can look back in your notes for how we kind of justify that and proved that. It has to do with converting to exponential form and taking a log on both sides and all of that. So like if I wanted to do this log base 3 of 81 and I didn't know the answer off the top of my head, in my calculator I could do log 81 divided by log 3. And that should give me my answer of 4. Okay. If I wanted to do something like this, I could do log of, and this might be tough to type in, but cube root of 5, and it's fine as long as I get that whole thing contained in the parentheses with the log, divided by log 5, and that gives me 0.3 repeating, which is 1/3. Okay? So this is your go-to if your brain is failing you for one reason or another. But if they can be done in your head, a lot of the times I find that they're easier to do in your head, okay, or quicker at least. Okay, 6 through 8, these are just using a calculator, and you'll notice these are all common logs, right? Okay, all common logs, which means that we can do these straight from your calculator just using the log button. We don't even need any crazy workarounds like this. So just real quick here, I would do log of 97234. I think it said round to the nearest hundredth, so this would be 4.99. Yeah. Okay, log 0.0003. I'm expecting something negative here because you need a negative number to turn into a decimal like that. Yep, and I end up with negative 3.52. And log of 412, 2.61. Okay, so now let's talk about the solving here. This first one, 7 to the power of x equals 343. Those are pretty convenient numbers because 343 is a power of 7. Okay, so you may be able to do one like that without necessarily putting it into your calculator or doing any of the other steps that I'm going to do for the rest of this. Sorry, I'm just trying to zoom this in a little better. There we go. So you may know this one off the top of your head. That was my point. Okay, I'm going to assume that you didn't know it off the top of your head. Anytime you've got an x up here in the exponent, we're going to start by taking a log on each side. So that this now says, and then, well, the reason that I did that is because then I can take this x off and put it in front of the log by the powers property. So I'm going to rewrite this as x times log 7 equals log 343. Okay. And then I can come in and divide by the log 7. Which cancels those out. And then it's just a matter of doing this calculation right here. So I'm going to end up with x equals, and let's see, log 343 divided by log 7. Yep, and I get 3. So again, you might have known 7 to the 3rd power off the top of your head. If so, great. If not, don't worry about it. Okay. Sorry, I'm just playing with this. Not trying to make you dizzy, but wondering if I can get it to be a little less blurry for you. Okay, so now looking at number 10 there. Number 10's got some other stuff besides just an exponential equation. It's got that extra 1,000 in there. I need to get rid of that first. Okay, so before I do anything here, I'm going to divide each side by 1,000. And that's going to give me 1.05 to the power of n equals 2. Okay? Now, because I have that n up in the exponent, now I can take a log on each side, just like I did before. I can take that n off and put it in front here. So now I have n times log of 1.05 equals log of 2. Okay? I'm going to divide my log of 1.05. And let's see, so log 2 divided by log 1.05 comes out to be 14.2. Okay, that's it. Okay, so on the next one, I'm going to treat it the exact same way. I've got a variable up in the exponent there. I don't have anything else outside of the exponential piece, so I'm just going to start by taking a log on each side. Okay, so I'm going to do log here, log here. Take this a plus 1 down and put it in front. And you'll notice that when I do that, I'll put this one down here. I'm going to put it in parentheses. That seems to sit better with people visually. 12 equals log 1,000. Okay? And then, just like before, I'm going to divide each side by that log 12. So this time, instead of just, like up here I had just x left, here I had just n left, this time I have a plus 1 left, and then I just have to do this thing. Okay, so log of 1,000 divided by log 12. Whoops, and I almost should put this up here. I almost made the mistake I keep warning you about. Make sure you close the parenthesis after the 1,000 there. Okay, and I get 2.78. And then just don't forget that because that's a plus 1, we still have to go in and subtract 1 from each side. And we end up with a equals 1.78 for this one. Okay, number 12, let's start it the same way. I'm going to take log on each side. Log, exponent down in front, so negative 2b times log 3 equals log 51. Taking a little bit of a shortcut here. I'm dividing by log 3, so I end up with negative 2b equals, sorry, just run a little low on space here. So log 51 divided by log 3 is 3.57, or 3.58, I guess, if I round. And then I want to divide by negative 2 here. What I would recommend is even if you write this down as 3.58 right here, that you leave this decimal in your calculator and just divide by negative 2 right here. Okay, where you're using that ANS, because that preserves the whole decimal, and you end up with 1.79. Oh, I'm sorry, it was divided by negative 2, so it's negative 1.79. Okay. This last one, number 13, I got lots of questions on this one in class. So I hope that you agree with me that the first thing we're going to need to do here is get rid of that 12, right? So I'm going to minus 12, and I end up with this log base 4 of x to the 5th power equals 6. Now, from here, I have a log on one side and no log on the other. All right, if I had 2 logs, I might approach this differently. But with only 1, the easiest thing to do from here is to spin this thing around and to put it back in exponential form. So that's going to look like this. 4 to the 6th power equals x to the 5th. Well, then I can figure out what 4 to the 6th power is. So I'm just going to use my calculator. 4 to the power of 6. 4,096 there. Okay, so I'm going to replace this with 4,096. And then it's just a matter of how do I get rid of a power of 5? Well, even before now, if I had given you something like that, you would know to take a 5th root, right? So from here, we're just going to do the 5th root of 4,096. And it's going to come out to be some crazy decimal, but in your calculator, that would be 5, math, x root, and then I'm going to say second answer. That just saves me. If that was like a decimal or something, I would, want to use the ANS rather than retyping it. And I get 5.28. Okay, so that's it for that page. I will continue in a second video for the next page, and we'll kind of just tackle this thing one page at a time. But hopefully that was enough of a refresher for you, and then I will also post this printed answer key for you as well if you just want to refer back to that.